What I'm going to run through here is how to make what we might call a flow diagram for the preparation of a serial dilution. So the idea here is this. We have a solution, a stock solution, and it is very concentrated, and that's not the concentration that we actually use the solution at. It's the concentration that it's stored at. Most of the time things are stored at very high concentrations, partly because it's better for shipping, and many of the chemicals are more stable at the high concentration. Other than when they're diluted, then they start to break down a lot faster. So in a laboratory, usually the solutions that we receive, the chemicals that we're going to work with in liquid form, often have to be diluted before we work with them. Now, we can either do a single step dilution, or we can do a dilution in a series of steps, multiple steps. One of the reasons why we would do multiple steps is because this way we can end up with smaller volume in the end, as opposed to a larger volume, as opposed to doing, a 1 to 1000 dilution, adding 1 to 999 to make 1000, which is very simple and straightforward. We might not need 1000 milliliters. We might need a whole liter. We might only need a small amount, and so you can either pipette tiny amounts, which could potentially lead to greater error, or you could do them in series. In addition, one of the main reasons we do this is because we often want multiple concentrations of a solution for testing. So for experimentation, you want several different concentrations, so you test it at all those concentrations. So you perform a serial dilution, and then you test them, whether we're looking at counting bacterial cells, or looking at chemicals to make a standard curve. There's numerous reasons why this is done in a biology lab, and probably chemistry labs, as well. So it's a good skill to know, and there's some just basics that you should get down. So I'm going to go through 3 real simple problems, each increasing kind of a little bit level of difficulty. Okay. There's no reason you have to have 3 tubes. You could have 4, 5, 6, 7, 8, or 2. I'm just using this as the beginning example. I've seen people get stuck on that. All right. So let's say we start off here. We would need to make a 1 to 1000 dilution, and we're going to do it in series, not in just a single step, but we're going to do multiple steps. So what we want to do is figure out, well, how are we going to make 1000? And so let's see, 10 times 100 is 1000, and then 10 times 10 times 10, would be 1000. So if we did a series of steps of 10, so if each of these zeros represents 10, okay, so that means in these 3 tubes here, each one is going to be a 1 to 10 dilution. Now, I'm writing this stuff out. It's a very good idea for you to actually sketch and draw this on a piece of paper, label everything I'm labeling before you do it. And if you will do that, and then you will follow it when you're physically pipetting liquid into containers, you're not going to mess up. You're going to do it right every single time. If you don't, and you kind of leave it up to I just going to remember how much to put in there, people will often do it wrong. And so I'll get to those things. So first off, label each individual tube. What is the dilution going to be? Any 0 we're going to have as 1 to 10, but you're going to see in these other examples we're going to have other numbers. So they're not going to be 1 to 10s. They'll be something else, right? Which we'll get to. So to make a 1 to 10 dilution, okay, how are we actually going to do that? Well, if we added 1 milliliter to 10, would that be it? And it's not quite right, okay? So when we look at the individual dilution, we can break this down, right? This dilution factor, so these are our dilution factors. This is the 1 to 10 dilution. That's the dilution factor for this particular one, the first step, and all these others as well. If we really simplify it, really want to make it as simple as possible, think about the numbers in terms of practical, real world things. So 1 milliliter of a solution, 1 represents 1 milliliter, right? And so 1 milliliter is how much we're going to add. So this is going to be the volume added. So I'm going to take from my stock solution and put into this tube 1 milliliter of the stock solution. So I get a pipette, and I pipette it out and put it into this tube. Now, 10 milliliters, 10 on the bottom here of the dilution factor is going to be my total volume. That's going to be once the 1 mill's added. So if I put 10 in there, 1 plus 10 would be 11. That'd make this a 1 to 11 dilution. So we don't want that. We want 1 less than 10. So in this tube, we're going to put 9 milliliters of water. Now, what is the solvent that you're going to use? That would be highly dependent upon the particular solution that you're making. I'm using water as the example here. It could be a variety of different sorts of solvents, just depending on what it is you're working with. So, but the numbers would be the same. Add the 1 plus the 9. That's 1 plus 9 is 10. That's a 1 to 10 dilution. So we need to get to 1,000. So what we have to do is repeat that. We're done with the stock solution. This is a series of dilutions, which means it's done in multiple steps, which means we're just going to continue from one to the next to the next. So that means I'm going to then put, I could prep this then ahead of time and say, oh, okay, so these are all going to be the same. So I could put 9 milliliters of water in all these just to start with. And then after I add my 1 ml of stock solution to the first one, I would mix it physically, mix it up, depending on what it was, how you would do it. Then I'm going to take from this tube 1 milliliter and put it into the second tube. 1 plus 9 is 10. That's a 1 to 10 dilution. But now what's happened is I didn't take it from the original. I took it from here. So now we would actually multiply these two dilution factors. So what we have here now is this particular tube is a 1 to 100 dilution of the original, right? 10 times 10 is 100, right? So you can see the idea of the series of dilutions. They kind of keep multiplying as we go along. So if I do another 1 to 10, how I would physically do it would be I would remove then 1 milliliter from this tube after I added that and mixed it. Put that 1 mil into this one. 1 plus 9 is 10. That singular one is a 1 to 10 dilution. But cumulatively, in series, as I've gone along the step, that's now 10 times this tube, which was 100. So when I put these together, that's 10 times 100 is 1,000. So I've made a 1 to 1,000 dilution in these particular 3 steps. You can do it all kinds of different ways. As long as the math works and you have the volume that you need in the end, really, you could do it in any particular way you want to do. But if the math doesn't work, then it's not going. It doesn't work. Period. And if you end up with a volume in the end that you can't use, for example, if you had to put it into a cuvette to put in a spectrophotometer, and you did a 1 to 2 dilution, and you added 1 milliliter plus 1. 1 plus 1 is 2. But your cuvette needed more than that because the larger cuvette, then you wouldn't really have enough to actually take the reading. So you'd have to up those volumes. So there's some things you would need to know, but as long as the basic math works, then it should work. Okay. So we're going to go over these 2 other examples using the same kind of idea here. So you can get a feel for it. So anytime you have a dilution problem, so when you're solving a dilution problem in a class or in an actual lab scenario, and you're like, okay, I have to make this series and I need to make my plan. All right, that's the flow diagram is really, it's really like your plan, for how you're going to do this. So now we'll take so we got the first one done. Now we're going to work on the second one. Make a 1 to 500 dilution. So you're like, okay, so I got a 1 to 499 to make 1 to 500, but I'm going to do it in a series of steps. Okay, multiple steps. And you could say every 0 is going to be a 10. So you could say, all right, I remember that from the last one. So here's what I'm going to do. I'm going to take 1 tube, 2 tubes, and these 2 tubes are going to be 1 to 10 dilutions. So I'm going to put 9 mils of water in each of them. And then I would take, from here, 1 mil. 1 plus 9 is 10. That's that. I could take 1 mil out of here. 1 plus 9 is 10. That's 100. But I need 500. So now I'm up to this tube here. Okay, so I need one more step. And if you remember what to have in the beginning, we had 1 mil is how much added. This is how much is going to be the total volume. It's best to actually write your dilution factor under your tube just so you know what you're trying to make. So I'm trying to make a 1 to 5 dilution, right? 5 times 100 then is going to be 1 over 500. That's going to be the dilution factor. So how do I make that? Well, if 1 is how much is added, so I'm going to add 1 from here, and 5 is the total, right? So 1 plus what is 5? 1 plus 4. So I would say, okay, I'm going to put 4 milliliters of water in here. 1 plus 4 is 5. That's a 1 to 5 dilution. If I did these 3 in a row, that's a 1 to 500 dilution. See, so if you need to do 50,000 or whatever it was, it doesn't matter. You just change the number of 1 to 10s that you might do. Okay. And now we're going to do this last one, 1 to 1600. And we're going to do slightly different, a little variation to this. Okay, to add a little something more to it. So instead of redoing it, we'll go through and say, you know what, the zeros still, again, every single time, but it's going to be 1 to 10 dilutions for each of them. So we'll just kind of leave that. And we'll change this here. Back up now. So 1 plus 9 is 10. That's a 1 to 10 dilution. 1 plus 9 is 10. That's a 1 to 10 dilution. Now we've got that here. Now we need the 16. Okay, so that's going to be so far a 1 to 100. Now what are we going to do? Okay, so you can do a couple things now. Now you have a few options, right? And it just depends on the situation and how you want to do this or how you might need to do this. So I could, following the same logic we just used, I could say, okay, I need to make a 1 to 16 dilution. 16 times 100 is 1600. So that's what I have to make. If I add 1 mil to what equals 16? 1 plus 15, right, is 16. And that would be it. However, let's just say, for example, for argument's sake, we either can't do that, or we don't want 15 milliliters total, or maybe it doesn't all fit in our tube that we're actually working with, and we're like, oh man, I have to do something different here because I have too much liquid to fit into my container. So another thing you can do when you have numbers like this, maybe it's 27, maybe it's something else. So you're going to say, how do I get that number? Again, you could do the 1 to the 27, 1 plus 26 is 27, or you could break them down, okay, into steps. So you can ask yourself, what two numbers multiplied by one another equals 16? So I could say, oh, okay, let's start off. Let's say, well, there's 1 times 16 is 16. There's 2 times 8 is 16, right? 4 times 4, is 16. So you can say, okay, I'm kind of getting the idea here. So let's say we did this. We're going to do 2 1 to 4 dilutions, right? And we're going to see how this works out. So I'm going to then make a 1 to 4 dilution. 1 plus 3 is 4, okay? So now I combine these two, that makes this a 1 to 400 dilution in this tube, but I'm trying to get to 1 to 1600. So if I did the same thing again, one plus 3 is 4. 4 times 4 is 16, right? So that means this tube now has the 1 to 1600 dilution in it, and I did it slightly different, so I kind of broke it down into 2 steps. So any numbers that can be multiplied to get a larger number, you can use that. So you can have a whole bunch of variety of options when coming up with a plan to make this, and it's really, again, partially could be your preference, and it partially could be dictated by some requirement of the lab or the thing that you're working with. All right. But for problems and just working out generic problems, if you're asked how would you make this and you need to draw up a plan like this, this is the system that you would follow.